Well, hello everyone and welcome again to the third episode in the series of electronics tutorials. In this tutorial we'll look at resistors. A resistor is used to reduce the flow of current on a circuit. A typical resistor is made up of a ceramic rod with copper wire wrapped round the outside. These are known as carbon film resistors. There are two wire terminals which come out of either side of the resistor so it can be connected into a circuit board. Resistors are not polarised, so they can be connected into a circuit board without having to ensure which end is connected to the positive and negative areas of the circuit. A resistor has an outer coating of insulating paint and has bands of colour painted onto it to display its value. Let's now create a simple resistor series circuit in the simulator and look at how the voltage and current are affected. We will use 3 resistors and a power supply which we will set to 24 volts. To create the series circuit, we place each resistor in line with the next and connect it with the power supply. We need to place our ground point, then adjust the resistors to the following value. Resistor 1, we'll set it to 5 ohms. Resistor 2, we'll set that to 7 ohms. And resistor 3 will set to 10 ohms. Now we start the simulation. Sometimes we cannot reach the exact value of resistance using a single resistor, so it is necessary to put them in series to get the desired value. Notice that the voltage drops as it passes through each resistor, but the current stays the same. Let's look at the equation we use to calculate the total resistance on this circuit. To calculate the total resistance on this circuit, we simply add the resistor values together. 5 ohms plus 7 ohms plus 10 ohms gives us a total resistance of 22 ohms. To find the total current on the circuit, we use Ohm's law. We know the total voltage supplied by the battery is 24 volts. And we know the total resistance is 22 ohms. To find the total current, we divide the voltage total by the resistance total. 24 volts divided by 22 ohms equals 1.09 amps. Resistor 1, 2 and 3 all have 1.09 amps of current flowing through them, but the voltage will drop as it passes over each resistor. To find the voltage drop across each resistor, we use Ohm's law and multiply the current over the resistor by the value of the resistor. The first resistor has 1.09 amps and is 5 ohms. 1.09 multiplied by 5 equals 5.45 volts. The second resistor has 1.09 amps and is 7 ohms. 1.09 multiplied by 7 equals 7.63 volts. And the third resistor has 1.09 amps and is 10 ohms. So 1.09 multiplied by 10 is 10.9 volts. Now if we take these values and add them together, we should reach the same value we have from our power supply. 5.45 plus 7.63 plus 10.9 equals 23.98. The total we have reached is only 0.02 volts of a difference to our power supply. We simply round this figure up to 24 volts. If the difference was much larger, then the calculations are wrong and need to be rechecked. Let's now create a simple resistor parallel circuit in the simulator and look at how it affects the voltage and current. We will use 3 resistors and a power supply which we will set to 15 volts. To create the parallel circuit, we place each resistor in parallel to the next and connect it with the power supply. We need to again place the ground point, then adjust the resistors to the following values. Resistor 1 is 6 ohms. Resistor 2 is 3 ohms. And resistor 3 is 8 ohms. Now we start the simulation. Notice that the current drops as it passes through each resistor, but the voltage stays the same. Let's look at how this is calculated and how we find the total resistance on the parallel circuit. To calculate the total resistance, we must first divide the value of each resistor by 1. Add the totals together, then again divide this total by 1. So the first resistor is 6 ohms. So we divide 1 by 6, giving us 0.17. The second resistor is 3 ohms. So we divide 1 by 3, giving us 0.33. The third resistor is 8 ohms, so we divide 1 by 8, giving us 0.125. We then add 0.17, 0.33 and 0.125 to give us the total of 0.625. To find the total resistance on the circuit, we now divide 1 by 0.625, giving us 1.6 ohms of total resistance on this circuit. Resistor 1, 2 and 3 all have 15 volts flowing through them. There is no voltage drop, but the current does drop over each resistor. To calculate the total current supplied by the battery, we use Ohm's law. 15 volts divided by 1.6 ohms equals 9.38 amps. To find the current over each resistor, we divide the voltage by the value of the resistor. The voltage over each resistor is 15 volts. Resistor 1 is 6 ohms, so we divide 15 volts by 6 ohms, giving us 2.5 amps. Resistor 2 is 3 ohms, so we divide 15 volts by 3 ohms, giving us 5 amps. And resistor 3 is 8 ohms, so we divide 15 volts by 8 ohms, giving us 1.875 amps. If we add these totals together, we should reach the same figure we calculated earlier to find the total current from the power supply. So 2.5 plus 5 plus 1.875 equals 9.375. we round this figure up to 9.38 amps. The total for our current is only 0.005 amps of difference to our original current total. We simply round this figure up to 9.38 amps. If the difference was of a greater value, then the calculations we have made are wrong and we need to look at them again. So as we can see, we can use the series circuit to get an increase in resistance, reduce the voltage and keep the current at the same level, and use the parallel circuit to produce a decrease in resistance, keep the voltage at the same level and reduce the current. The following chart shows a complete list of colour values for resistors. Each colour band on a resistor corresponds to the values shown. For example, if we had a 4-band resistor, band 1 is red, band 2 is green, band 3 is orange and band 4 is gold. Using the chart, we can see the value of the resistor is 25 kilo ohms and has a tolerance of 5%, which means it is 5% above or below the value shown. If we have a 5-band resistor, band 1 is yellow, band 2 is violet, band 3 is black, and band 4 is red, and band 5 silver. Using the chart, we can see the value is 475 ohms with a tolerance of 10%. In the next video, we will look at capacitors and place them in series and parallel circuits. I hope you've enjoyed this tutorial. Please feel free to ask questions and leave comments. All the best.